Hi, I'm Neil deGrasse, and today I will tell you 100 amazing facts about the moon you have to know. Subscribe, and let's start. Number 1. Born from a planetary smash-up. The leading idea says a Mars-sized body, nicknamed Theia, hit the young Earth, blasting out a super-hot debris disk that later gathered into the moon. Apollo rocks back this up. Earth and moon have virtually identical oxygen isotope fingerprints, meaning their material was thoroughly mixed in the impact. Yet the moon is iron poor and depleted in easy-to-boil elements, exactly what you expect from crust and mantle debris cooked in a giant collision. Number 2, why do we always see one face? The moon spins once in the same time it orbits Earth, so the same hemisphere stays pointed at us. This is synchronous rotation from long ago tidal locking. Earth's gravity raised bulges in the young moon and drained rotational energy until its spin matched its month-long orbit. It does rotate. One lunar day is equal to one lunar orbit, so it only seems not to. Number 3, why do total solar eclipses fit so perfectly? A total eclipse works because the sun is 400 times bigger than the moon, yet 400 times farther, so they look the same size in our sky. When alignment is just right, the moon's disk exactly covers the sun's face. Over geologic time, these perfect totals will fade since the moon is drifting away 5 inches per year. Number 4, the moon has a smell. Apollo astronauts said lunar dust that hitched a ride into the cabin smelled like burnt gunpowder or hot metallic fireworks once they took helmets off. The moon itself has no air. The odor appeared only when dust met oxygen inside the lander, likely a brief chemical reaction with solar wind-charged grains. Spacesuits came back smelling like a campfire after a walk on the moon. Number 5, the moon is drifting away. Laser measurements show the moon recedes from Earth by 1.5 inches per year. Reason? Tides. Earth's tidal bulges drag against the ocean floors, transferring a bit of Earth's spin to the moon's orbit and nudging it outward. This tiny yearly increase has been confirmed since Apollo placed retroreflectors on the moon. Number 6, the moon is surprisingly dark. Up close, the moon isn't glowing. It reflects only about 12% of sunlight. Roughly the brightness of worn asphalt. That low reflectance known as albedo is why the Maria looks so inky, yet against a black sky the moon still seems bright. NASA even describes its surface color as old. Well-worn asphalt, your eyes just have no brighter reference in the night. Number 7, surface temps swing from blistering to brutal. Lunar noon at the equator can reach about 260 degrees Fahrenheit on the day. After the lunar sunset, it can plunge to minus 280 degrees Fahrenheit at night. With no air or oceans to spread heat, the surface bakes in sunlight and radiates heat away at night. Number 8, the moon is slightly lemon-shaped. Global maps of lunar gravity and topography show the moon is subtly stretched, with bulges facing toward and away from Earth. Think very gentle lemon, not a football. This shape likely froze in early on, carved by tidal and rotational forces when the moon was hotter and spinning faster. Number 9, the moon turns red during a total lunar eclipse. During totality, direct sunlight is blocked by Earth. The only light reaching the lunar surface has been filtered and bent through Earth's atmosphere, which scatters blue light and lets red-orange hues pass, projecting all the world's sunsets onto the moon. More dust or clouds on Earth, a deeper crimson blood moon. Number 10, 1/6 gravity. Jump like a superhero. On the moon, gravity is only about 1.62 meters per second squared, roughly 1/6 of Earth's 9.81 meters per second squared. That means your weight there would be about 17% of what the scale says on Earth. Quick hack, take your Earth weight and divide by 6 to get your moon weight. This low pull is why Apollo astronauts took those long, floaty hops. Number 11, why can we see 59% of the moon from Earth? Patient observers glimpse about 59% of the lunar surface, not just 50%. Tiny wobbles called libration let us peek a bit around the edges over a month, revealing extra strips near the limbs and poles. At any single moment, you still see roughly half. The 59% adds up over time as the viewing angle shifts. Number 12, the far side isn't dark. We always see one face because the moon is tidally locked, but both hemispheres get day and night, about 14 Earth days of sunlight, then 14 days of darkness each month. Dark side is just a nickname. The far side simply faces away from Earth, not away from the sun. Same sunlight, different view. Number 13, a quarter Earth-sized rock. The moon's diameter is about 3,476 kilometers or 2159 miles, which is roughly 1/4 of Earth's 12742 kilometers or 7,918 miles. That small size helps it cool faster than Earth and explains why it lacks a global magnetic field today. NASA's measurements peg the mean lunar diameter precisely at 3,474.8 kilometers. Number 14, the moon really does quake. Moonquakes are real, triggered mostly by Earth's gravity tugging at the moon, a slow squeeze that builds stress and releases it. Deep moonquakes start hundreds of kilometers down and are generally weaker than typical earthquakes. Here's the wild part. Without air or water to damp vibrations, a moonquake can ring on for tens of minutes and sometimes hours. Apollo seismometers felt thousands of these shakes, giving us our first X-ray of the moon's interior. Number 15, 4 kinds of moonquakes. Apollo seismometers recorded deep moonquakes with approximately 700 kilometers down, likely driven by tidal stresses, shallow moonquakes with between 50 to 220 kilometers that can shake hard but are rare. Thermal quakes from the crust cracking as it reheats after the 2-week lunar night, and impact quakes from meteoroids hitting the surface. That catalog came from the Apollo seismic network. Number 16, why the moon isn't a planet. By the International Astronomical Union rules, a planet must orbit the sun, be round, and clear its neighborhood. The moon fails the first test because it orbits Earth. So it's classified as a natural satellite even though it's geophysically world-like. Also, size doesn't decide this. The moon's diameter is 2159 miles, while Pluto's is 1477 miles. Pluto is smaller. But it orbits the sun, and so is a dwarf planet under the IAU scheme. Number 17, Earth's only permanent natural satellite. The moon is our planet's lone permanent natural satellite, orbiting at 384400 kilometers. Occasionally, Earth snags tiny mini-moons for a short time, like the object 2020 CD3, but they drift away. The moon stays, the tagalongs don't. Number 18. Which planets have no moons? Only Mercury and Venus lack natural satellites. Their closeness to the sun makes long-term capture of small moons difficult, and past impacts likely stripped any that formed. Every other planet has at least one. Number 19. The moon doesn't have its own moons. Astronomers have never confirmed a moon of the moon. Tiny satellites would be ripped from stable orbits by Earth's stronger gravity and the moon's small hill sphere. You may hear about the Kordylewski ghost moons. But those are diffuse dust clouds near the Earth-Moon L4 point, not solid mini-moons. No natural submoons have been found. Number 20, the moon's phases depend on its position. What we call phases is just sunlight on different parts of the moon as it orbits Earth. When Earth sits between the sun and moon, we see the fully lit face, or full moon. When the moon is between Earth and the sun, the lit face points away, known as the new moon. Basically, what we see is simply sunlight on different portions of the moon's face as it orbits Earth. Nothing on the moon is changing shape. Learn the pattern once, and you'll spot it every month. Number 21, the moon has 8 phases, 1 lunar month, about 29. 5 Earth days, has cycles through 8 phases. New moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last third quarter, and waning crescent. Number 22, low gravity is lunar bounce. The moon's surface gravity is about 1/6 of Earth's, so you don't get pulled down as fast. That's why Apollo footage shows astronauts leaping and hopping instead of walking normally. With weaker pull, each push-off carries you farther and longer before landing. Result, a springy glide-like gait that feels almost like slow motion. Engineers still train with one of 6G simulations to practice that movement. Number 23, how the moon makes tides. The moon's gravity pulls ocean water into a bulge on the side facing it. A second bulge forms on the far side due to inertia. As Earth turns, coastlines pass through these bulges. That's high tide. Between them is low tide. The sun and Earth's rotation also tweak tide heights, but the moon is the main driver. Number 24, the moon is slowly making our days longer. The moon's tides act like a brake on Earth's spin, stretching ocean bulges and rubbing energy away. Net result, the length of day increases by 2. 3 milliseconds per century. It's tiny per lifetime, but over geologic time it adds up. Future clocks will need the occasional tweak because of lunar tide drag. Number 25, fifth biggest, second densest. The moon is the fifth largest natural satellite, and among major moons, it's the 2 ND densest. Only Jupiter's moon Io is denser. That density moon with 3.34 gram per cubic centimeter against Io with 3.53 tells us the moon is rocky, not an icy lightweight. This size and density combo helps explain its strong surface gravity for a moon and why it's a powerful shaper of Earth's tides. Number 26, fast orbit, slow month 27.3 versus 29.5 days. The moon circles Earth at 1 kilometer per second, completing a sidereal orbit in 3 days, but because Earth is also moving around the sun, the moon needs extra time to catch the sun-Earth line again, making the phase month 29.5 days. Fast lap, longer light cycle, hence our predictable phases. Number 27, 3 main moon rocks. Lunar samples show 3 major rock types: basalt, the dark volcanic, and orthosite. The light highlands and breccia, the impact welded mix. These exact rock types are confirmed in Apollo collections and teaching sets. Basalt makes the dark Maria plains. An orthosite dominates the bright highlands. Breccia forms when impacts break and fuse older rocks together. Number 28, bright highlands versus dark Maria. The moon has 2 main terrains, bright higher highlands and dark lower Maria. The Maria are solidified basaltic lava that filled low areas. They cover about 16% of the moon's surface. The highlands are generally older than the Maria. That contrast makes the moon's light versus dark look. Number 29, why so many Maria on the near side? Most Maria are on the near side we see from Earth. Scientists don't fully agree why this near side clustering happened. Studies show 99% of exposed mare lavas erupted on the near side. One leading idea involves more heat-producing elements on that side. But it's still debated. The pattern is clear. The cause isn't. Number 30, regolith, moon dust with big jobs. Regolito is the moon's blanket of crushed rock and dust. Future crews plan to use it on site, shielding habitats from radiation and micrometeoroids, building roads, bricks via sintering or 3D printing, and extracting oxygen from its minerals, leaving useful metal powders. Using local regolith cuts mass we must launch from Earth. Key for long-term bases. Number 31, inside the moon, crust, mantle, and a small partly molten core. Apollo seismometers revealed a layered moon, a crust roughly 50 kilometers thick atop a mantle, and a tiny core with a fluid outer layer and solid inner seed, likely wrapped by a partially molten boundary zone. That structure explains the moon's weak magnetic signals and ancient volcanism without requiring an Earth-like big iron core. Number 32, moon dust is like sandpaper in a vacuum. Lunar dust isn't soft. It's a razor-edged, glassy powder made by billions of micrometeoroid hits that shatter and melt rock. Those jagged grains cling electrostatically, grind seals and suit fabrics, and can irritate eyes and lungs when brought into habitat air. Apollo crews even reported a burnt gunpowder smell once dust met oxygen. Future missions treat dust as a top engineering and health hazard. Number 33, a world of craters and one giant scar. On the near side alone, scientists tally more than 3,000,000 craters bigger than 1 kilometer across. The biggest lunar impact basin is South Pole Aitken, about 2,500 to 2,600 kilometers wide and up between 8 to 10 kilometers deep, an ancient bullseye on the far side. That's a crater larger than Texas and deeper than Mount Everest is tall. Number 34, how lunar craters get their names. Craters aren't named at random. The International Astronomical Union officially names lunar features, drawing mostly from deceased scientists, scholars, and explorers. It also honors deceased astronauts and cosmonauts for crater names. This tradition grew from early mappers like Michael van Langren and Giovanni Riccioli, but today the IAU's working groups make the final call. Number 35, tallest lunar mountain, meet Mons Huygens. It rises about 5.5 kilometers or 18,000 feet above nearby plains, more than half Mount Everest's height. It's a rugged peak along the Apennine Range, sculpted by ancient basin-forming impacts. Astronomers use shadow lengths and laser altimetry to peg its height against local terrain. Number 36, no breeze, no rain, no weather. The moon has no real atmosphere, just a whisper-thin exosphere, so there's no wind, no rain, no clouds. With no weather to erase them, tracks and rover marks can last for ages. Think of the surface like a near-vacuum dust world. Grains don't get blown around by air because there isn't any. Number 37, footprints forever. Why Apollo tracks still look fresh with no wind or rain. Bootprints and rover tracks don't get washed away. They fade only under a slow drizzle of micrometeorites. That space weathering is so gentle that impressions can persist for millions of years before they blur out. One big reason the Apollo sites remain crisp today in orbiter photos. Number 38, why lunar shadows look so dark. On the moon, there's no air to scatter sunlight, so shade isn't gently filled in like it is on Earth. It drops to inky black. That lack of Rayleigh scattering makes contrasts extreme. Sunlit ground is dazzling, shadowed ground is nearly pitch. There is a little bounce light from the gray soil and earthshine, but not much. Explorers have to treat every shadow like a black box. Number 39. Lunar eclipse is like Earth's shadow. A lunar eclipse happens when the Sun-Earth-Moon lines up, so Earth's round shadow falls on the moon. The darkest part, or umbra, can turn the moon copper red as sunlight filters through Earth's atmosphere, like a global sunset projected onto lunar rock. Total, partial, and penumbral eclipses depend on how deeply the moon crosses that shadow. It's our planet doing the blocking, not the moon dimming itself. Number 40. Earth-Moon matching oxygen is a big clue. Apollo rocks revealed the moon's oxygen isotope ratios are nearly indistinguishable from Earth's mantle. Unlike most meteorites, that chemical fingerprint points to a shared origin. Material from early Earth mixed with impactor debris that later coalesced into the moon, a cornerstone of the giant impact picture. Number 41, perigee versus apogee tides. When the moon is closest, its gravity makes bigger than usual tides, often called perigee spring tides. When it's farthest, the lunar pull is weaker and tidal ranges are smaller. Perigee doesn't create storms, it just raises the water higher. Storms are a separate weather thing. Number 42, not all full moons look the same size. When the full moon is closest to Earth, known as perigee, it looks bigger than when it's farthest, or apogee. At perigee, a full moon can appear up to 14% larger in diameter and about 30% brighter than at apogee. That's the supermoon effect, subtle to the eye, but real. Number 43, what counts as a blue moon? Astronomers use two accepted meanings: a monthly blue moon, the second full moon in one calendar month, and a seasonal blue moon, the third full moon in a season that has 4. Thanks to the 29.5-day lunar cycle versus our calendar, these pop up every 2 to 3 years. The next monthly blue moon is May 31st, 2026. Number 44, blue moon isn't blue. A blue moon today usually means the second full moon in a calendar month. It doesn't look blue. This modern usage became popular after a mid-20th century mix-up and stuck in everyday language. Result, the color stays normal, only the calendar quirk is special. Number 45, what's a supermoon? Really? A supermoon is a full moon near perigee, its closest point to Earth, so it looks up to 14% larger and 30% brighter than a faraway full moon near apogee. Typical distances, perigee 363,300 kilometers. Apogee 405500 kilometers. The popular term was coined in 1979. Many define it as a full new moon within 90% of its closest approach. Number 46, the moon's synchronized spin. The moon spins once each time it orbits Earth, like a dancer always facing the audience. That lockstep motion is called tidal locking or synchronous rotation. The result, we always see the same lunar half from Earth. This happens because gravity traded spin for orbital stability long ago. Number 47, the moon's violent past. Billions of years ago, the moon lived through a late heavy bombardment, a burst of massive impacts. Scientists see signs of that ancient pummeling in huge impact basins in Apollo rock chemistry. The timing, roughly 4.1 to 3.8 billion years ago, when many big space rocks slammed the inner solar system. Think cosmic hailstorm that scarred the moon for good. Number 48, moon's dark seas is frozen lava. The moon's dark patches, or maria, are solidified basaltic lava. They formed when lava flooded low-lying impact basins long ago. These flows spread widely, creating flat, dark plains. The maria cover about 16% of the lunar surface. Finding exact eruption vents is hard due to overlapping flows and impacts. Number 49, two things all moons share. All natural moons share two basics. They orbit a planet, they're natural satellites, and they don't make their own light. They reflect sunlight we see from Earth. That's it. Orbit a planet, shine by reflection. Number 50, first footsteps on the far side. China's Chang'e 4 made the first soft landing on the moon's far side on the 3rd of January 2019, touching down in Von Karman crater. Because the far side never faces Earth, the mission used the Kachao relay satellite beyond the moon to beam data home. Its U-22 rover has ground-truthing terrain, rocks, and regolith, our first up-close look at this hemisphere. This was the milestone that turned the hidden half into mapped, measured ground. Number 51 and far side is more conductive. Scientists using South Korea's Danuri orbiter found stronger, more widespread magnetic fields on the moon's far side. These magnetic signals imply the far side conducts electricity better deep below the surface. Danuri's magnetometer mapping also highlights distinct crustal magnetic anomalies. Lunar induction studies with Danuri data are being used to estimate conductivity structure. The far side appears more electrically conductive than the near side. Number 52, road trip to the moon. The moon is about 2,38855 miles from Earth on average. If you could drive non-stop at 70 miles per hour, the math says roughly 142 days. So half a year on cruise control, no bathroom breaks. Number 53, the moon's path is tilted, not over our equator. Earth's moon doesn't orbit above Earth's equator. Its orbital plane is tilted. Because of an 18.6-year cycle, that tilt relative to the equator ranges 18 to 28 degrees. This is why the moon's rise-set positions drift so widely over the years. NASA notes the orbit plane slowly rotates, driving this cycle. Number 54, colder than Pluto. Some polar craters never see sunlight, so heat can't build up. LRU's diviner instrument measured lows near minus 415 degrees Fahrenheit inside Hermite crater. That's colder than Pluto's average surface temperature. Why? Permanent shadow plus no atmosphere to move or hold heat. Result, ultra-cold traps that can preserve ice. Number 55, the moon's exosphere. The moon has an ultra-thin exosphere, not a thick air layer. It's made mostly of helium, neon, and argon. It's about 100 trillion times less dense than Earth's air at sea level. So it can't breathe, block radiation, or slow dust. It's practically vacuum. Near the surface, it's roughly 100 molecules per cubic centimeter, about 1,600 per cubic inch, trillions of times thinner than Earth's air. Number 56, lava plains you can see from home. The moon had powerful volcanic eruptions long ago that poured out basalt. These flows filled low areas and formed the Dark Maria, vast lava plains visible from Earth. Maria covers more than 15% of the lunar surface and records multiple eruptive episodes. Samples and mapping show volcanic activity spanned billions of years in early lunar history. Those dark patches are ancient seas of frozen lava. Number 57, the moon's invisible tail. The moon trails a long stream of sodium atoms, a faint comet-like tail. It stretches hundreds of thousands of miles, too dim to see with your eyes. Sunlight pushes the sodium outward. Tiny meteor hits knock atoms off the surface. Cameras tuned to sodium light can detect it, especially near the new moon. The moon wears a giant invisible sodium scarf. Number 58, first object to reach the moon. The Soviet probe Luna 2 became the first human-made object to reach the moon in September 1959. It was a fast impactor that struck the surface, proving we could send hardware from Earth to the moon. Impact site near the lunar Maria on the side facing Earth. This milestone opened the door to later flybys, landers, and rovers. Number 59, the moon's tiny iron core. The moon's core is very small, about 1 to 2%, that is under 4% of its mass. It's mostly iron, with a solid inner core 150 miles radius and a molten outer core extending to 205 miles radius. Overall, the core spans 20% of the moon's diameter, much less proportionally than Earth's. This small, mostly quiet core helps explain the moon's weak global magnetic field today. Number 60, helium-3 in lunar soil. The moon's surface contains helium-3, a rare isotope on Earth, embedded in the regolith by the solar wind. Helium-3 is studied as a potential fusion fuel because DIC-3 reactions make far fewer neutrons, meaning less long-lived radioactive waste. Engineers and space agencies actively research mining concepts, but practical use is still an open ear and die question. Number 61, no global magnet to hide behind. Unlike Earth, the moon has no planet-wide magnetic field today, only patchy, crustal, magnetic swirls. Without a strong magnetosphere, the surface is more exposed to the solar wind and space radiation, which helps charge and loft dust and shapes the ultra-thin lunar exosphere. Missions measure this directly and model how ancient lunar magnetism faded over time. Number 62, Tycho crater's dinosaur-era impact. The moon's Tycho crater formed about 108 million years ago. Scientists know this from radiometric dating of impact melt glass tied to the Tycho event. So yes, Tycho hit when dinosaurs still ruled Earth. Number 63, allergic to the moon. The Apollo 17 astronaut Harrison Jack Schmitt had a reaction to lunar dust. After tracking dust into the lunar module, he had sneezing and red eyes for hours. He dubbed it lunar hay fever, highlighting dust as a health risk. This episode is a key lesson for future moon explorers. Number 64, how many full moons to equal the sun? By the magnitude scale, the sun is about 14 magnitudes brighter than a full moon. Roughly 4,000,000 brighter. So you'd need hundreds of thousands of full moons to match the sun's brightness. But you can't fit that many. The full sky is 4,1253 square degrees. The moon is 0. 5 degrees across, even filling the whole sky gives only 2,060,000 moons. Still short of the brightness needed. Number 65, 95% full isn't half as bright. About 2.4 days before or after full, the moon is 95% illuminated, but it looks about half as bright as true full. Why? At an exact full moon, the surface gets an extra boost called the opposition surge, which sharply peaks the brightness. That peak is roughly 0.7 magnitude brighter than 95% phase, around a 2x difference to your eyes. Number 66, escape velocity. To break free of the moon's gravity, a rocket must hit about 1.48 miles per second. That's far easier than Earth's, with 6.96 miles per second, which is why lunar landers can be smaller and why ascents from the moon need less fuel than Earth launches. Apollo trips from Earth to lunar orbit took about 3 days, consistent with these energy scales and the geometry of the transfer. Number 67, spacesuits lose weight on the moon. An Apollo spacesuit with life support weighed about 183 pounds on Earth, but only 30 pounds on the moon because lunar gravity is roughly 1/6 of Earth's. Same suit, same mass, the weight changes with gravity. That lighter feel lets astronauts hop around while still hauling a hefty system. Number 68, what happened to the Apollo 11 flag? Lunar reconnaissance orbiter images show flag shadows at most Apollo sites, but not at Apollo 11, supporting Buzz Aldrin's report that the flag fell when the ascent engine fired. Even flags still standing are likely sun-bleached, nylon under unfiltered EUV, and radiation would fade toward white. In short, the first flag probably toppled, and surviving ones are ghosts of their original colors. Number 69, Apollo 11's site. Apollo 11 chose the Sea of Tranquility Mare Tranquillitatis for landing because it looked smooth and safe for landing. Despite the name sea, it's a flat volcanic plain, ancient basalt that filled a low basin long ago. So the first lunar footsteps were on hardened lava, not a watery shore. Number 70, no humans on the moon since 1972. The last footsteps were in December 72, when Apollo 17 astronauts Gene Cernan and Harrison Schmitt wrapped up humanity's sixth and final lunar landing. In total, 12 people walked on the moon between 1969 and 1972, and every surface mission since has been robotic. That long pause is why upcoming Artemis landings are such a big deal. They'll return crewed boots to the regolith. Number 71, the moon steadies Earth's tilt. Earth's axial tilt drives seasons, and the moon helps keep that tilt from wandering wildly. Classic dynamics work shows the moon damps large chaotic swings that a moonless Earth could experience. With the moon, obliquity stays comparatively tame over long times. Later simulations refine the exact range, but the stabilizing role of the moon remains the consensus. Number 72, rules of the moon. No country can claim the moon. Space is open for all to use. The moon must be used exclusively for peaceful purposes. Military bases, maneuvers, and weapons tests on the moon are forbidden. YMDIS are banned in orbit and on celestial bodies. Think global commons, shared access, no sovereignty. Number 73, the moon illusion. The moon looks bigger near the horizon. but photos show it's the same size there as high in the sky. It's a brain trick. Our perception stretches the horizon seen and makes the moon seem larger. Scientists agree it's an optical illusion, though the exact cause is still debated. No special lens needed, your eyes are doing the magic. Number 74, same phase for everyone. No matter where you are on Earth, you're seeing the same lunar phase at that moment. The orientation can look flipped between hemispheres, but the phase itself is the same worldwide. So a full moon is full for everyone, just at different local times. Number 75, moon trees from Apollo 14. On Apollo 14, astronaut Stuart Roosa carried hundreds of tree seeds in lunar orbit. After the mission, the seeds were germinated and planted across the United States and abroad. Many grew into thriving moon trees, living mementos of the flight. Species included sycamore, loblolly pine, sweet gum, redwood, and Douglas fir. NASA continues to track and celebrate these historic plantings. Number 76, Earth has phases too. From the moon, Earth shows phases just like the moon does from Earth. They're opposites. When we see a full moon, a lunar observer sees a new Earth, and vice versa. On the moon's near side, Earth appears in nearly the same spot in the sky. It only wobbles slightly. Number 77, eclipses reversed from the moon. A lunar eclipse for us equals a solar eclipse as seen from the moon. Earth's disk slides in front of the sun. When Earth fully blocks the sun, its atmosphere glows red around the edge. This same filtered light makes our eclipsed moon look reddish. So Earth casts the shadow, the moon or a viewer on it sees the sun go dark. Number 78, Apollo's lunar treasure haul. Across 6 Apollo landings between 1969 and 1972, astronauts returned 842 pounds of rocks, cores, and soils. Those returns were packaged as 2196 individual samples and are curated at NASA's Lunar Sample Laboratory facility in Houston for study and future missions. Over the years, Subdivision for Research has created more than 100K catalog pieces, but they all trace back to that original 382 kilograms. Number 79, only 2 sports were played on the moon, golf swings and a javelin on the moon. On Apollo 14 on 1971, Alan Shepard famously hit 2 golf balls, and crewmate Edgar Mitchell tossed a makeshift javelin, a sampling tool handle across the from aeroplane, space history's first lunar sports moment. Photos in NASA history still point out where the ball and javelin landed. Number 80, so far humans have landed only on the moon. Across all of spaceflight history, the only world where people have set foot is the moon. 12 Apollo astronauts between 1969 and 1972. Every other destination has been visited by robots only. That makes the moon our first and still only off-Earth foothold. Number 81. Your phone versus Apollo's computer. Today's cell phones are vastly more powerful than the Apollo guidance computer. The AGC had about 2 kilobytes RAM, 36 kilobytes ROM, and ran near 2 megahertz, tiny by today's standards. Modern phones exceed AGC performance by hundreds to millions of times. 400 times is a conservative way to say it. Engineers analyzing the AGC confirm its very low computational throughput. So yes, your pocket device dwarfs the computer that guided humans to the moon. Number 82, no air is no twilight. Twilight needs an atmosphere to scatter sunlight after sunset. The moon essentially has none. So when the sun sets on the moon, the sky turns dark fast without a lingering glow. This sharp day-night switch is a direct result of no air to scatter light. Polar shadows can stay dark for eons because sunlight never reaches them. Number 83, Babylonians mapped the moon's cycles. In the 5th century BCE, Babylonian astronomers recorded repeating lunar cycles. They recognized the Saros pattern that lets eclipses be predicted. Their lunar system became the earliest systematic astronomy on record. Number 84, Gene Shoemaker's ashes on the moon. Planetary scientist Gene Shoemaker's ashes were carried aboard NASA's Lunar Prospector and delivered to the moon when the probe impacted in 1919. His remains were placed in a polycarbonate capsule for the trip, an extraordinary memorial for a pioneer of astrogeology. He is widely noted as the only person interred on the moon. Number 85, why we call it the moon. Moon comes from Old English mona, related to Latin mensis, month. The link reflects how people measured time by lunar phases in early calendars. So our word for the moon is literally tied to the idea of a month. Number 86. The moon in China. In Chinese philosophy, yin and yang are paired forces. Dark and light, receptive and active. The moon is yin, the sun is yang, a classic cultural association. Yin is linked with softness, coolness, and reflectiveness, matching the moon's gentle glow. This pairing shows harmony between opposites, not conflict. It's one of the most enduring ideas in traditional Chinese thought. Number 87, animal circulunar clocks. Some animals sync key behaviors to the moon's phases. This is called a circulunar rhythm. On Australia's Great Barrier Reef, many corals spawn around the full moon, releasing eggs and sperm in mass events. The regular lunar light cycle provides a precise natural timer. Number 88, why the moon looks upside down in the south. Travel across the equator and the moon appears rotated because your viewing angle flips with latitude. Southern hemisphere observers see the same phases, but the lit portion grows and shrinks in the opposite direction. And familiar features look rotated, not because the moon changed, but because you did. The amount of rotation roughly matches the change in latitude. A true 180 degrees flip only occurs pole to pole. Number 89. Transient lunar phenomena or mystery flashes mostly aren't volcanoes. They are short-lived glows or flashes people report on the moon. Modern studies show many are likely meteoroid impact flashes or observer instrument artifacts, not active volcanism. NASA now monitors the moon to catch these tiny impacts on camera. Number 90, National Moon Day. Every July 20th, National Moon Day marks humankind's first footsteps on the moon in 1969. Congress has repeatedly recognized the date, most recently with a 2024 House resolution designating July 20th as National Moon Day, tying the celebration to Apollo 11's historic landing and Neil Armstrong's first step. It's the annual moment to spotlight lunar exploration and its legacy. Number 91, full moon, shorter sleep. Some studies find people sleep a bit less and fall asleep later around the full moon. A lab study saw about 20 minutes less total sleep and less deep sleep near full moon. Field data showed people go to bed later and sleep shorter in the days before a full moon, likely due to extra evening moonlight. Moonlight can nudge our body clocks. The effect is small, but shows up in multiple studies. Number 92, first wheels on the moon. On November 17, 1970, the Soviet rover Lunokhod-1 became the first vehicle to drive on the moon. It rolled down from the Luna 17 lander the same day and began moving across Mare Imbrium. First to move across the surface is what makes it historic. Date, lander, and first drive status are all from mission records. Number 93, polar clues, Chandrayaan-1's ice radar. India's Chandrayaan-1 flew a mini-SAR radar over the lunar poles and saw the telltale signature of water ice in dozens of permanently shadowed craters. Radar reflections matched what you'd expect from frosted ice hiding where sunlight never reaches, building a patchy map of cold-trapped deposits. Think freezer isles at the moon's poles, small, scattered, but real. Number 94, L-Cross kicked up water at the South Pole. NASA's L-Cross mission slammed a spent rocket into Cabeus crater and then tasted the ejecta with a trailing probe. Instruments detected water vapor and ice grains in the plume. Direct local proof that polar cold traps store H20. It wasn't a trickle. Multiple lines of evidence in the impact debris confirmed water. Number 95, why it matters, polar ice is space utility juice. Lunar ice isn't just for science. Melt it for drinking water, split it into oxygen for breathing, and crack it into hydrogen plus oxygen for rocket fuel via electrolysis. That turns the poles into potential gas stations for deep space travel and sustained moon bases. Cutting what we must launch from Earth. Number 96, LRU 50000 loops and counting. NASA's Lunar Reconnaissance Orbiter has passed 50000 orbits of the moon. It launched June 18, 2009 from Cape Canaveral. It was the first U.S. robotic lunar mission in over 10 years. A key goal, make a 3D map to scout landing sites and resources. It has captured more than 2.9 million images of the moon. Number 97, the moon's far side is a natural quiet zone. Think of it as a giant noise-canceling headphone. The bulk of the moon blocks Earth's radio chatter, creating the most radio quiet spot in the inner solar system. Perfect for ultra-low frequency telescopes to listen for the universe's dark ages. That's why astronomers are pushing to formally protect it from future interference, satellites, relays, and mining. Number 98. A weird volcano hides on the far side. Most lunar volcanoes are dark basalt, but Compton-Belkovich is different. A rare silicic granitic-like volcanic complex that's unusually rich in thorium. This chemistry screams un-moon-like, hinting at pockets of extra heat and a more complicated volcanic history on the far side than we expected. Number 99. The moon has a solid, iron-dense heart. Recent geophysical sleuthing indicates a solid inner core 500 kilometers across. About 15% of the moon's diameter, wrapped by a fluid outer core, small world, serious metallurgy. Its density is close to iron, making the moon a miniature cousin of Earth's layered interior. That inner core helps explain subtle clues in lunar rotation and seismic-style data reanalysis. Number 100. Meteor showers puff the moon's dusty air. When Geminids and other showers hit, tiny meteoroids smack the surface and blast up plumes of powder, briefly thickening the moon's ultra-thin dust cloud on the impact-facing side. After the shower passes, the cloud thins again, but the moon stays wrapped in a faint, permanent dust exosphere. It's real, it's lumpy, and it shows up strongest during Geminids. And that's all. What surprised you the most? Leave it in the comments and subscribe. See you soon, your friend Neil.